Okay, so what we're looking at today in this video is annuity investments. An annuity investment is an investment that has regular deposits made over a period of time that allows it to grow at a compounding rate. So what we're basically starting with is a compound interest, and then each time we compound that that amount, we add an extra amount. So it's like adding an extra $100 each time you do a compound. Okay. And then you do the same process going through there. And what we've got here is, just by the way it's written, is you can see Vn plus 1 equals Vnr plus D is a recurrence relation. So keep that in mind. That's a recurrence relation for an annuity investment. So if you have to show this sort of, not there, that's the first work example I'm going to go. You got a table and you have to show like each successive, so each recursive amount. Okay. And as you can see here, that's what the equation looks like. That's what the terms are there for. They're all fairly similar. The key point here is the deposit amount, really. That's the part where you need to be really conscious of what's going on. Okay. Now, an investment with an addition of a regular payment in terms of, we're not talking about recursion now. We're talking about like basic future value. Now, the book gives this, and the book also, in some of the worked examples, loves to use that equation. Don't use Finance Solver. Use Finance Solver anytime you can. Okay, so that's where you need to be really careful with that. Use Finance Solver because it'll generate the values you need, and that's why I put a little screen clipping of the Finance Solver from the calculator. So let's have a look at our first worked example. So as you can see here, that's the equation you use. And so what we've got here is an initial deposit of $1,000 was made on investment taken out over 5 years at a rate of 5.04% per annum, with the interest calculated monthly. An additional deposit of $100 each. So that's our, oops, thought I'd change that. That's our D, okay? That is our V0. Okay, so it's at 5 years. That's going to be part of our rate. So let's write rate there. Okay, and we complete the table. So we've got our Vn, so that's our V0. So basically what we're looking at here, this is our V0. So we're looking at V1, V2, V3, V4, V5. And as you can see there, the rate is 5.04% per annum. And so basically what that means is, in terms of our equation, remember our equation here R, it's the interest rate per period, and it's monthly. So let's go ahead and go R equals 5.04 divided by 12, and that will give a value of 0.42. And it's that value you're going to divide by 100. So let's just do an example over here. So I'm going to go oops, I'm picking on the wrong one there. Sorry about that. I'm going to go plus 100. I actually meant to go from there to start with. So I'm going to go V1 equals, well, it's going to be V0. So V0, as we said it before, was $1,000. Okay, and then in bracket, we're going to have 1 plus 0.42 divided by 100. And then we've got our plus 100 here. And that will give a value of 1104.20. So that's what the value I'd put there, 1104.20. All right. So then V2, that's, I take that value and put that value there. So in this case, it's going to be 1104.20. Okay. And then I'm going to do the same thing here. I'm going to go V2 equals all that stuff plus 100, and that'll give another value. Now, I could go all through them, but that's just using up time. But that's the process. You're going to use this value in the, where it says Vn. You do your calculation, add 100 to it, you'll get the Vn plus 1. Take that value from here, and bring it down to here, use it there, plus 100, and then you'll get another number which goes here, and you use that here, do your calculation, plus 100, and you'll get another number which you then use here, and that'll generate your fifth term at that point. Okay, so that's how you work out using that one there. Okay, so now we're going to go into worked example 25. Now before we do that, I want to go up to Finance Solver summary sheet up here, and this is the one we're interested in at the moment. It's this annuity investment, so basically for superannuation. And the interest rate here is always going to be positive. The present value, so that V0, is going to be negative because essentially you're giving the money to the bank, and you're giving the bank money, it's a negative value in Finance Solver. And then if you go, the payment is negative because you're giving money to the bank, but what you get at the end is they give you money, so that becomes a positive value. Okay, so just keep that in mind when we're going through these next set of worked examples. Oops, this one here. Okay, so Helen currently has 2,000 in the savings bank. Savings account needs average an interest rate of 8% compounded annually. So let's start off thinking V0. Let's go with V0. That's my R, and that's annual, so that means 1. Okay. She wants to calculate the amount that she will receive in 5 years. So that's essentially our time that when she plans to go on an overseas trip. So if she deposits, so what we're saying is our N is 5 because it's 5 years. Our R is 8, as we've shown up here. We're starting at negative 2,000 because remember, we're giving money into the bank, so that becomes negative 2,000. And we're making, on a yearly basis, we're going to deposit $6,000. So deposit negative, and then we go PPY, well, that's where I get the 1 from, and that's what I put there, and I'll put that in my calculator, and I get an answer. Okay, and if you do that, you'll get an answer of 38,000, oops, sometimes it, 38,138.26. Now, just remember from your question, it says corrected nearest $1,000. So let's just write that out as our answer as $38,000. Okay. So, so that would be our answer for that part. For B, if she places her $2,000, increases her deposits to $7,000 into a different savings account that can offer 9% compounded annually. So we've got different values here, but remember, that's still the same. That is now negative 7,000 because that's what she's going to be putting in each year, and that has changed. Okay, do the same thing, and your answer for that will be 44,970.22. Now, nearest $1,000 for that is 45,000 because that's what they're after, corrected at nearest $1,000. And so that answers A and B. So C is basically saying calculate extra amount saved by investing $7,000 each year at a 9% per annum compared to that. It's basically just going 45,000 minus 38,000, and that will give you $7,000. Okay, so now we're going to move on to worked example 26. Okay, and basically the idea of this is it's saying how much money do you need to save to give you so that you can have a desirable retirement income. So do you have enough money to live nicely on? Okay, so in this case, Andrew is aged 45 and he's planning to retire at 65 years of age. So that's 20 years time. He estimates that he needs $480,000 to provide for his retirement. So he needs to have that when he gets to 65. His current super fund has a balance of 60,000 and is delivering 7% per annum compounding monthly. So some key points here. Okay, that is going to be our FV or what we call our VN. And the reason that's because that's what our final value is going to be. All right. Has a balance PV, also V0. The time here is 20 years times 12 because it's compounding monthly, and that's our interest rate. Oops, R. Okay, and that's shown here. So that's given there. Remember, you can just type that into your calculator and it will give you the answer. So you don't have to go, oh, what the hell's 20 times 12? It will give it to you. Put 7 in. Remember, I'm putting, in terms of the using the finance solver, I'm putting 60,000 in, so I put minus 60,000. My FV is 480 because that's what I'm going to get given to me at the end. And what we're after here, monthly contributions here, that means we're looking for PMT. Okay, and so that's what we'll get PMT, that's what we're solving for. So in this one, you put that in your calculator and you're going to get PMT is equal to 456.26. Okay. Okay. So in B, what it says is if in the final 10 years before retirement, Andrew doubles his monthly contribution calculated from A and finds a new lump sum amount available for retirement. So basically what you need to work out in this particular case is this value here after 10 years. That's why this number here is no longer 20, it's 10, because I need to find how much I'm going to have in my super account after 10 years. Okay, so that becomes 10 times 12 now. Interest rate's still the same. It's still got 60 grand put in there at the start. My payment, and the reason I zoomed in because I'm not going to fit it otherwise. And remember, this is going to be a negative number. I'm going to negative 4.5626. I put that into my calculator. All right. This PPY and CPY is 12 because it's monthly. I should have mentioned that a little bit earlier. Okay, I put that into my calculator and I get a value of 199,550. I should have put a 0 there. 0.58. Okay, so that is what I have space in that super after that 10 years. Okay, and then I change it. That's when I take this number, let's put it in lovely blue, and that now becomes this part here. Okay. All right, so that's where I'd move that number down to. So I'd move that number down to here. Okay, my payment, okay, is still it's going to be slightly different. It's based on that 456, but it's going to be minus 456.26 times 2. Where did times 2 come from? Where am I here? Doubles the monthly contribution calculated from A. Okay, that's where that times 2 comes from. All right, so I put that in my calculator and I'm solving for that. Okay, and that will give me a value of 558,970.9. Okay, so basically it's find a new how much you'd get. So instead of 480,000, I'm going to have close to 560,000. Okay, so let's look at part C. And part C is basically doing this part again, this part again here, but changing from 7 to 9. Okay, so my V0, it's still going to be the same as before. So let's just put that as the blue. Okay, I'm still going to have, make sure I'm using the right colors. Let's put this green is going to be there. And I'm still after basically that unknown. Okay. All right. So the value you get from that. So the answer you'd get from doing all that is a value of 665755.37. Now, part C asks us to subtract basically this value from this one. So let's do that here. So that's going to be 665755.37 minus 558970.90. That'll equal to 106,784. And then there's some decimal points there. But the reason I haven't worried too much about that at the moment is it's asking for to the nearest $1,000. So our answer for C is $107,000. Okay, so you'd write a nice little statement saying, so if you increase the interest rate to 9% for the final 10 years, and you would expect an extra $107,000, correct to the nearest $1,000. Okay, so that's how you'd answer that particular type of question. This one here is work example 27, and this one it's one of those times where I've just taken the screen clipping from the page and used that as my approach, because this clip is getting quite long as it is. All right, so this is one where he's planning to retire at 55. He's already 50. He's got an annual salary of 70,000. Employee contributions are 9% of his gross monthly income. That's an important point to remember. Jared also contributes a further $500 a month as a salary sacrifice, and he pays these from his salary into his super fund. Usually that means you do it before tax. The super fund has been returning interest rate of 7.2% per annum, so that's our the compounded monthly, and his current balance in the super fund is $255,000. Okay, so that's his annual salary. And so where we get, so calculate the total monthly contribution to the super fund. Well, that's where we're looking at. His contributions are 9% of his gross monthly income. Okay, so basically that's going to give, if you do 9% of 70,000, remember 9% is like saying 9 divided by 100, and that will give you 0.09. So your answer would be, for that part, would be 525, but he's also adding an extra $500. So he's putting in $1,025 per month. So let's look at part B. Calculate the lump sum that he can receive for his planned retirement at age 55. Remember, he was 50 to start with, so we're going to add on, it's basically 5 years. So now let's use Finance Solver. And the reason I put that there is because this is where I said the book likes to use this equation. Don't use Finance Solver. So it's going to be 5 times 12. That will give you 60. My interest rate, our interest rate here is 7.2. Okay. You just got to be careful you use the right one. You don't use this one for this point. I want to use the one for the has interest rate 7.2. It's compounded monthly, so these are going to be 12. Okay, our PV, which is this one here, so that's going to be, and remember, just to give you our present value, that'll have to be negative. Okay, so you'd put in negative 255, basically because you're giving this money to the bank. Oops, I should have forgot that part was, it only covers there. Payment is 1,025, again, negative. You put that into your calculator and you will get an answer of, as we say here, that much there. Okay, so that's that value, this value here would go into there. Okay. Now, part C, calculate the monthly. So he's got two options. He's retired at 55 and he sets up an annuity so he can get a regular income after he's retired. One's a perpetuity, one's a reducing balance annuity. Now, basically the difference is perpetuities, as we've done before, a perpetuity will go on forever, basically because it's using that base amount to provide. Reducing balance annuity is basically something where I say, have 60 grand in the bank, and I'm using that up over time. So it might go for 30 years. And if I say 30 years, I'll get a certain amount each month. But after 30 years, I've got zero money left. So that's the basis of a reducing balance annuity. Okay, so let's have a look. So write the perpetuity formula. Remember, our perpetuity formula is this one here. My V0 is going to be the value we just worked out, so this value here, okay, and we've told us an R of 8%, so you work that through, and what you find is you're going to have that much, 35 grand per year, so monthly, divide that by 12, so basically what you're going to have is a monthly payment of just shy of $3,000, okay, and that's basically 50% of what this person's previously earned, okay? And this is the statement. So they've asked for a statement here, I think, for memory. Oh no, it didn't ask there, but it's a good habit to do some sort of statement like that. Okay. Now D is it's a reducing balance annuity. Again, they're using this equation here. Don't use that equation. Use your finance solver. So I've just put another finance solver thing there for you. And so if we look at this one here, we said this was for 25 years. So that becomes 25 times 12. Our interest rate was 8% because we've done that already. Our PV in this case comes from that V0. So it's going to be that $438,000 value. So I write that there as minus 438,869.90. Okay, so that's this bit here we just did. We've done that bit. We've talked about the R. Now our payment will end up being positive because we're getting paid that money. But our final value is 0 because after 25 years, no money anymore. And it's a monthly value, so that's going to be 12. I put that into the calculator, and what I get for a monthly payment is, let's put in a different color, is going to be 3387.27. So you can also already notice a difference that in terms of monthly payment here, if you do a perpetuity, it's nearly 3 grand. If you do as an annuity, it's 3 grand, 3,400. And in this case, it's about, because you're going to have to multiply this by 12 to give yearly. And I'm going to take that yearly value and divide it by 70,000, which is what they've done there. And we find that it's 58%. Okay, the key point to take away from this, so this one finishes, you got no more money after 25 years. Okay, this one here will still be going strong. Oops. You'll be going strong after 25 years. Your choice if you have to make that choice. Okay, thank you. Bye.